Okay, we are in section 14.5. We're going to deal strictly with matrices in this lesson. We're just going to deal with them as mathematical objects. We're going to add them, subtract them. We're going to multiply by them. And we're going to work our way up to figuring out how you divide by a matrix. But that's not in this lesson. That's to come. Okay, so first of all, a matrix is this sort of mathematical quantity here. And so how do I know when two matrices are equal? Well, two matrices are equal if and only if their corresponding entries are equal. And it goes without saying that their indices have to be equal as well. A 2 by 3 matrix is not going to equal a 1 by 2 matrix. Those are definitely not going to be equal. So in this example here, I'm claiming that these two matrices are equal. They're each 2 by 2. We have 2 rows and 2 columns. And notice that their first entry, their 1, 1 entry are both the same. And the same thing for their row 2, column 2 entry. Those are both the same. And so if these are the same everywhere, then their row 1, column 2 entry, 7 and 1 minus y, have to be equal as well. And so if this is the case, then y must equal negative 6. And also their row 2, column 1 entries need to be the same as well. And so 2x would need to equal 5, and so x equals 5 halves. And so we just have matrices are equal if all of their entries are equal. All right. So now we're going to take two matrices and we're going to add them, subtract them, and do scalar multiplication. This is similar to the operations that we learned when we did vectors. And just so you know, a vector is actually the same mathematical quantity as a matrix, just with only one row or one column, depending on how you think about it. Okay, so in order to add and subtract matrices, they have to have the same index again. And the way you add or subtract is you just simply do the entries. You add the row 1, column 1 entry to the row 1, column 1 entry in the second matrix. And you can see here I'm naming matrices with capital letters. I have matrix A and matrix B. These are both 3 by 2 matrices. We have 3 rows, 2 columns. And so in order to add them together, I'm going to get a result that's a 3 by 2 matrix. And to get the first entry, the column 1, row 1 entry, I need to add the column 1, row 1 entries. And so this is simply 12, 1, 0, negative 2, negative 1, 13. And I just got that by adding corresponding entries, right? So from row 2, column 2, I added negative 2 and 0 and got negative 2. Similarly, you can do that with subtracting the entries. And so if I take the A entries minus the B entries, well, in my row 1, column 1, I get 1 minus 11, that's negative 10. 0 minus 1. Negative 2 minus negative 2 is 2 plus 2. Negative 2 minus 0. Negative 4 minus 3. And 1 minus 12. Okay, and now in this third example, I want to know what 3 times A is. And so I'm taking the matrix A and I'm multiplying it by 3. And so in order to do that, you're simply going to just multiply each entry by the scalar. And so this is going to be 3 times 1 is 3. 3 times 0 is 0. 3 times 2 is 6. 3 times negative 2 is negative 6. And then negative 12, 3. All right, and then I'm going to leave number 4 for you to do. This is a couple of steps. I want you to do 3 times A, and I want you to subtract 2 times B from 3 times A. Okay, so now that you can, here are more operations. And so how do I do this? And this is just written out without the names. So I'm going to follow order of operations. And so inside the parentheses, I'm going to do that first. And so I need to do the multiply inside the parentheses first. So nothing is changing here. And now I'm going to multiply that 5 in. Okay, now I'm going to do inside the parentheses, I'm going to do this addition. And so this is going to be And finally, I can do 2 times that matrix. So my final answer, 18, 16, negative 22, 20, 36, negative 12. Okay, now I'm going to solve this equation. Now this is a matrix equation, but it solves just like an algebraic equation. So if I have 2 times the matrix X minus the matrix A equals the matrix B, which is what this equation says, I can solve for matrix X by adding matrix A to both sides. So I'm going to add a matrix A on the right to both sides. And so I get 2 times matrix X equals matrix B plus A. And to get the X matrix, I would have to divide by 2 next. So 1/2 times matrix B plus matrix A. And so what I've done is I've solved the equation first in matrices. And now to get the matrix they're looking for, I just have to simply take 1/2 times matrix B plus matrix A. So B plus A is 4, negative 2, and I'm just using the matrices now. So 4, negative 2, 10, negative 6, 2, 4, and then I multiply by 1/2. And so X, matrix X, is 2, negative 1, 5, negative 3, 1, 2. So that's X, this matrix. All right, last topic, we're going to learn how to multiply matrices. Multiplying matrices is the most difficult operation we're learning today. It's actually like a dot product in vectors, only you have to do several subsequent ones. Okay, so this is important. The way we matrix multiply, we don't want the indices of the matrix to be the same necessarily. You can multiply matrices sometimes when their indices are the same, but the real rule is that the number of columns in the first matrix have to be equal to the number of rows in the second matrix. And so matrix multiplication is not what we call commutative. The product A times B is not necessarily the same as B times A. And so the way you do A times B is you take the rows in A times the columns in B. Rows in A times the columns in B. Okay, so I'm going to go through 4 examples here. In this first example, let me show you how we worry about whether or not we can even multiply. So to know if we can even multiply or not, we have to look at the indices. So matrix A is a 2 by 2 matrix. Matrix B is a 3 by 2 matrix. Okay? And so what are the number of columns in matrix A? That's my first matrix. Well, the number of columns is the second number in the index. The number of rows is the first number. So look at the number of rows in matrix B. That is 3. Okay? 2 and 3 are not the same. So in this case, A times B is not possible. So this matrix, these 2 matrices, I cannot multiply together because the number of columns in matrix A is 2, but the number of rows in matrix B is 3. Okay, so let's move on to the next example. In this next example, I look at the index of matrix A. It has 1 row and 3 columns. 1 row by 3 columns. If you look at matrix B, it has 3 rows and 1 column. 3 rows and 1 column. Okay, so when you take 2 matrices and you're allowed to multiply them together, I'm going to write them with their indices like this. You get a matrix, AB, and as long as the number of columns in the first matrix is equal to the number of rows in the second matrix, you get an answer. And what's interesting is that the index of the answer here is going to be, it's almost like these numbers that are alike, they cancel, and the answer for the index of the answer is going to be a 1 by 1 in this case, a 1 by 1. And let me show you how that works, and you're going to really see the dot product here. And then we're going to do some harder examples next. So what is AB in this example? Well, you take the dot product, so each entry, the dot product of the row in matrix A with the column in matrix B. Well, I only have one row in A and one column in B, and so I'm going to do the dot product of A dot B. And so I'm going to take entry 2, multiply it to 0, and then I add 5 times 1, and then I add 6 times 3. Right? Because remember, when you did the dot product of matrices, you multiplied corresponding parts and then added. And that's exactly what I've done here. I've taken the first element times the first element, those are the circles, the second one times the second one, and the third times the third, and now I'm going to add them. And so this is actually a matrix, but it's a 1 by 1 matrix. And it is 0 plus 5 plus 18, so 23. So it's the 1 by 1 matrix 23. This is exactly a dot product of two vectors. All right, so let's do a more interesting example. And this third example here, number 3, say, I'm going to look at A, the index of A, I have 1 row, 3 columns. And I'm going to multiply that to B, and B has 2 rows, 3 columns. Oh, I can't multiply these. No, so this cannot be done. AB is not possible. And this is not possible because the number of columns in A is not equal to the number of rows in B. So 3 is not possible. Let's do 4. So this is a big example here. And this is our final example. Okay, so I'm going to take A, which is a 3 by 3, and I'm going to multiply it by B, which is a 3 by 3. Notice that my rows and columns are the same. The columns in A are the same as the rows in B. And so my product AB is going to be what's left, which is a 3 by 3. So in this answer, we're not going to get that trite little dot product, just one number. We're going to get an actual matrix with 9 numbers in it, 3 rows, 3 columns. Okay, so I'm going to move this because I need some more space. Okay, so to get AB, I'm going to have a 3 by 3, and I already know that because I figured it out from the indices. You take the row in column A, and you're going to dot product it with the first column of B. So first row of A dot first column of B. Okay? And so I'm going to take 1 times negative 1 plus 0 times 2 plus 2 times 1. So 1 times negative 1, negative 1, plus 0 times 2, so negative 1 plus 0, plus 2 times 1 plus 2. So I get negative 1 plus 0 plus 2, that's 1. So 1 was the answer I got from the dot product of the first row with the first column. First row, row 1, column 1. Row 1, column 1 dot product goes in the 1, 1 entry. Now to get the row 1, column 2 entry, I'm going to take row 1 times column 2 now. So I'm going to dot product row 1 with column 2. Okay, so I'm going to do row 1 dot column 2. Change to a slightly subtler shade of green. Okay, so row 1 dot column 2, so I'm going to take 1 times 6 plus 0 times negative 1 plus 2 times negative 5. So that's 12 minus 10, that's 2. So I did row 1 dot column 2 to get my row 1 column 2 entry. For the last entry in row 1 of the answer matrix AB, I take row 1 of column A and I dot product it with column 3 of matrix B. So this is 1, 3. I'm doing row 1, column 3. So I take 1 times 3 is 3, plus 0 times 4, so still 3, plus 2 times 2, that's 7, plus 4, so that's 7. And so now I have my first row done of my product matrix. Now I'm going to the second row. I'm going to work in blue. To get the second row of column of matrix AB, I take the second row of A, and now I'm going to multiply the second row of A times the first column of B. So row 2, column 1. Row 2, column 1 goes in that spot. And you just do a dot product. So it's 6 times negative 1 plus negative 5 times negative 1 plus 7 times negative 5. So negative 6 plus 5 minus 35. Yikes. So that's negative 36? Yeah, negative 36. Now to get the next entry, I'm going to use a different shade of blue here, maybe. I'm going to do row 2 times column 2. Row 2, column 2. And so I'm going to dot product 6, negative 5, 7 with 6, negative 1, 5. So that's 6 times 6 plus negative 5 times negative 1 plus 7 times negative 5. Didn't like that. Okay, so that's 36 plus 5 minus 35. Is that what I did last time? Hold on. Darn it. I made a mistake. Okay, I should have, when I did row 2, column 1, I should have done 7 times 1. I was looking at the wrong spot. So that's plus 7. So negative 6 plus 5 plus 7 is 6. So this should be a 6. Okay. I thought 2 negative 35s was odd. All right, so now when I do row 2, column 2, 6 times 6 is 36, plus negative 5, let me get back to my color, plus negative 5 times negative 1 is plus 5. And then plus 7 times negative 5 is minus 35. So it's negative 30, so this is 6. All right, now let's do our row 2, column 3. Row 2, column 3. Row 2, column 3. So I'm going to do 6 times 3 plus negative 5 times 4 plus 7 times 2. All right, so I get 18 minus 20 plus 14. Is that 12? All right, last, let's work with some warm colors here. Okay, so now to get my third row of product AB, I'm going to work with the third row of matrix A. I'm going to multiply it to the first column, then the second column, then the third column. And that will get me these last 3 entries, and I want you to try to do that. And I will check it when we grade your homework.